The system shown consists of cables AB, BC, BD knotted together at B. Cable BD supports the mass at D. Determine the magnitude of the tensile forces in cable AB and BC. Okay, you're asking how are we going to do this? Well, the first step is to find or draw a free body diagram of the diagram. So here's what we're going to do. We have our X plane and the Y plane as well. And we need to draw our forces. You always need to remember that tension is always away from the point. So here we have a tension right here in AB, but you want it to be away from point B. So you have in this direction FAB. And you also have another tension in the string BC, the cable BC, and that force is also away from the point B. We also need to note the angles here, 50 degrees and 20 degrees. And we also have an angular mass, 30 kilograms. So let me take this chunk off here. Okay, that's good. And we have the hanging mass of 30 kilograms. Well, how can we change 30 kilograms to a force? Because 30 kilograms is a mass. We're going to need to use the equation F equals ma. Where F is in newtons, your mass is in kilograms, and your acceleration is in meters per second square. So here we have F equals ma. Our mass is 30 kilograms, and the acceleration provided we're on Earth is 9.81 meters per second square. So multiplying this together, what do we have? We get 294.3 kilogram per meter square, which is also the same as newtons. So now we can rewrite our force here as 294.3 newtons. Okay, and now the next step is to break each force into its x and y components. So here, starting with FBC, we need to break the force into its x and y components. Where's my cursor? Okay, there it is. Alright, so here, in order to find the x component of FBC, you want to look for the component of this force that's going in the x direction. Well, since this angle is 50 degrees, your x component will simply be the force BC times the cosine of 50 degrees. Also for the y, that would be FBC sine of 50 degrees. So the same applies to FAB down here. Let's go down a bit. Okay, there we go. So the same applies for FAB down here. So the x component would be FAB cosine of 20 degrees. But since this is going to the left, we have to add a negative right here. And also the y would be negative FAB sine of 20 degrees. Since this question is in equilibrium, we know our equilibrium equations. Sum of forces in the x direction has to be equal to 0, and sum of forces in the y direction has to be equal to 0 as well. So taking the sum of the forces in the x direction, we have FBC cosine 50, and we have negative FAB cosine 20 degrees. So here we can write down an equation for summation of f of x, FAB cosine 50 minus FAB cosine 20 degrees. Or are they both FABs? Okay, that's FBC. My mistake. And this is equal to 0. So now for the summation of forces in the y direction, which is summation fx, we have one here, FBD sine 50. So summation of forces in the y equals to 0. 0 equals FBD sine 50 degrees. And then we also have negative FAB sine 20 degrees. And also do not forget your force, your hanging mass is 294.3 newtons. So we also need to include that as part of the equation. Negative 294.3 newtons. And that is equal to 0. I put that on the left side. So here we have a system of equations. FBC cosine 50 degrees minus FAB cosine 20 degrees equals to 0. And 0 equals FBD sine 50 degrees minus FAB sine 20 minus 294.3. Well, there are different ways of solving this system of equation, but I would just go through the generic method of using substitution. So in the first equation, we can easily solve for either one of those variables. Whichever one you use does not matter. I would solve for FAB just because. So here, moving FAB to the right side, we have FBC cosine 50 equals FAB cosine 20 degrees, and dividing both sides by cosine 20, we have FBC cosine 50 over cosine 20 equals to FAB. So now we can simply plug in our FAB into the second equation right here. So now we have 0 equals FBD sine 50 degrees minus FBC and there should be a C here, and this is also a C right here. So going on, we have cosine 50 over cosine 20 times sine of 20 degrees minus 294.3. Okay, now we need to solve for FBC since that is the only variable in the equation. So first of all, we can move 294 over to the other side, 0.3, and factor out FBC on this side. That would leave us with sine 50 degrees minus cosine 50 sine 20 all over cosine 20 degrees. Okay, and now we divide both sides by the coefficient of FBC. So dividing both sides by this value. Okay, dividing both sides by this value cancels out on this side, and then plug in this into your calculator. We have FBC equals 553.1 newtons. Now in order to find our FAB, we simply plug FBC back into the equation we solved initially for FAB. So here we're going to have FAB equals to, well, our new value for FBC is 553.1 cosine of 50 degrees divided by cosine of 20 degrees. And plugging this into your calculator, we get 378.3 newtons. So let me cut this and bring it down here. Okay. So this right here are values for FBC and also FAB as well.